Hello everyone, this is Jude Leonard from Department of Physics, St. Joseph's College of Arts and Science, Cuddalore. Today we are going to discuss about Zener diode. We already seen a video regarding types of diodes, and Zener diode is an important type of a diode which has a number of applications in it. Let me discuss about Zener diode. Here we can see the Zener diode is not like any other PN junction diode. It is not a normal diode. It has its own significance. The idea is it is normally operated only in the reverse bias condition. We know that PN junction diode doesn't operate in reverse bias condition, while it operates only in forward bias condition. And this Zener diode operates only in reverse bias. It means that N type of material is connected to the positive terminal and P type of material is connected to the negative terminal. So this is reverse bias condition, and in particular Zener diode conducts only in the reverse bias condition. And it is not used as a Zener diode practically. It means PN junction diode we should not use such as Zener diode practically, because it is not operated in reverse bias condition. And this reverse bias condition can be achieved by using highly doping material in it. If the PN junction diode is highly doped, we can especially design the diode as a Zener diode. Before understanding the working of Zener diode, there are many important terms which we have to understand the meaning of it. That is easy for you to understand the working of Zener diode. And the one of the terms is the avalanche breakdown. What is avalanche breakdown? After a certain reverse voltage is gained, when we connect voltage across the junction, we know that in reverse bias, so there is a certain kind of reverse voltage, amount of reverse voltage. During that condition, the minority carriers get sufficient kinetic energy. As I told earlier, the minority carriers in both the sides of P and N junction gets kinetic energy due to the applied voltage, due to the applied reverse voltage. Due to this strong electric field, they gains kinetic energy, and this kinetic energy is sufficient for the free electrons to move in the in that material, in that P or N type, whether it may be a majority or a minority charge carriers. The next important term in the working of Zener diode is Zener breakdown. As avalanche breakdown, there is another type of breakdown happens in the working of Zener diode, and it is called as Zener breakdown. This happens when the PN junction diode is highly doped. As we discussed earlier, by adding impurities, by increasing the doping level, we can make the normal PN junction to Zener diode. By increasing the concentration of that impurity ions while doping, will make the crystal or the sample becomes highly doped, and it turns into a Zener diode. These high concentration of impurity ions causes higher concentration ions in the depletion layer. So as we mentioned earlier, due to this very high amount of doping, the same kind of concentration ions in the depletion layer gets increased due to the same kind of applied reverse biased voltage, and as a result the width of the depletion layer becomes thin when comparing to the normally doped diode, and this particular phenomenon makes the depletion layer also conductive in nature. And this phenomena, this point is called as Zener breakdown. And the voltage at which this breakdown, the reverse voltage what we are giving to the junction, at which this particular breakdown called as Zener breakdown, and the voltage is referred as Zener voltage. The next one is the difference between Zener and avalanche breakdown. And we know that by understanding the working of the attainment of Zener, the avalanche and the avalanche breakdown and the Zener breakdown seems to be somewhat tricky in understanding. And this difference, this table brings you some idea outline about that exactly what happens in Zener and in avalanche breakdown phenomena, and that this difference helps you to understand, but there are differences in both Zener and avalanche breakdown. As you see in the table, the Zener happens when it is when the material is heavily doped, and while in avalanche it is enough for us to dope it lightly to reach the avalanche effect. And the next point is this breakdown voltage such a strong electric field across this narrow layer. This voltage which makes the breakdown as called as Zener breakdown, we know that, and this makes the electric field across this narrow layer, across the depletion layer. And while in avalanche, electric field is not strong enough to set a voltage in this particular layer. And next one is this electric field is strong enough, very strong enough to rupture the covalent bonds. We know that the recombination of electron hole pairs in the layer, and this happens while the electric field given across the junction is strong enough to make these kinds of electron hole pair. And in avalanche, minority charge carriers collide with the semiconducting atoms. We know that the minority carriers collides with both the semiconducting atoms to generate electron hole pairs, whereas electric field is not strong enough, so this doesn't occur due to the electric field. And the last one is electric that is Zener diode exhibit negative temperature coefficient. Very important point. Breakdown voltage decreases as the temperature increases, so it shows the negative temperature coefficient. And while in avalanche breakdown, it exhibits positive temperature coefficient. It means breakdown voltage increases with the increase in temperature. This is a very important point which makes the difference between the Zener breakdown and avalanche breakdown. From the graph we can note that reverse breakdown of the Zener diode operates the region in the breakdown. It is called as Zener region. In this region, the voltage across Zener diode remains constant, but the current changes depending on the supply voltage. By giving the reverse applied voltage, we can alter the voltage across the Zener diode. And Zener diode is operated in the region when it is being used as a voltage regulator. The application, one of the application of Zener diode, important application is we can use as a voltage regulator. This like any other diode, it also has VA characteristics in both the modes, forward characteristics and reverse characteristics. And forward characteristics, we know that it is very similar to an ordinary Zener diode in the previous slide. It is almost identical to the forward characteristics of a PN junction diode. and the next one is in the reverse mode, reverse characteristics. As I already discussed, as we increasing the reverse voltage, there is a small reverse saturation current I0, and this is due to the minority charge carriers as a result of thermal agitation. At a certain value, the knee point, it becomes the there is a decreased dip in that reverse current, reverse voltage at a certain value suddenly drops and it is very sharp. This is the indication that the breakdown has occurred, and by definition we know that it is a Zener breakdown, and usually we denote it by VZ. From the graph we can note that reverse breakdown of the Zener diode operates the region in the breakdown. It is called as Zener region. In this region, the voltage across Zener diode remains constant, but the current changes depending on the supply voltage. By giving the reverse applied voltage, we can alter the voltage across the Zener diode. And Zener diode is operated in the region when it is being used as a voltage regulator. The application, one of the application of Zener diode, important application is we can use as a voltage regulator. This table shows the different types of regulator circuits where we use Zener diode as a component. It has both advantages and disadvantages in it. This table reflects kind of significance of a Zener diode in regulators. Especially in regulators, the applications of Zener diode is more, and there are both advantages and disadvantages in each and every regulator circuit. Coming to the application part, it is highly used as LEDs. We know that by varying the concentration of the doping materials in PN junction, we can vary the types of colors. It is used as display devices. It very basically 7-segment display. We use kind of LED only in many kind of lighting applications, using TV remotes, older VCRs, and nowadays in optical fiber communication and free space communications we also use these kinds of Zener diodes as regulators. And it has advantages, important similar advantages as a PN junction diode, very fast responses even in a nanoseconds, more communications used to for communicative purposes, generally LEDs, and voltage level, you know, it increases from 1.7 to 3.3, which makes it is easily accessible in solid state circuits.